Oh hey class, it's Professor Kevin and I'm going to teach you today about forces. Now I don't want to bore you guys, but I think y'all have the potential to figure this problem out. So follow me. So now we're going to go with Professor Timmy to solve this problem. Alright, now we're going to go look for Professor Timmy and we're going to do the prompt. Professor Timmy, what the flux are you doing?
Alright, Professor Kevin, let's go to the problem. So there are two forces, F of A and F of B, that are applied to an object whose mass is 8 kilograms. The larger...
No!
What's the matter, Kevin?
What's the matter? What's the matter? I think you're doing the wrong problem. God damn!
I don't think you should be telling me what we're doing, Kevin. You're the one that got a 2, you stupid.
That hurts! You're tearing me apart, Professor Timmy!
I'm sorry, Professor Kevin. I couldn't resist from calling you stupid. But, Kevin, let's just get back to the problem. So, the larger force is F of A. When both forces point due east, the object acceleration has a magnitude of 0.5 meters per second squared.
However, when force A points due east, with force B pointing due west, the acceleration is 0.4 meters second squared. And they want us to find the magnitude of FA and the magnitude of FB.
Alright, so the first step to solving this problem is listing the givens and unknowns. F of A is unknown and F of B is unknown. Acceleration for the first situation is 0.5 meters per second squared. Acceleration for the second situation is 0.4 meters second squared. And the mass is 8 kilograms.
And I think we should start by drawing a free body diagram after listing the givens. So in the first body diagram you have the mass right here, and they're both pointing in the same direction. And we have a large arrow for FA and a smaller arrow for FB. And here clearly it says acceleration is 0.5 meters second squared. And then in the second situation, FB is kind of pulling back on FA, so it reduces its acceleration to 0.4 meters second squared.
So the third step is finding F net for both instances. So the F net of the first instance is equal to F force of A plus force of B equals mass times acceleration, which in terms we have already because of the givens, 8 times 0.5, which gives us 4 newtons. And for the instance of 2, it's 8 times 0.4, which gives us 3.2 newtons. Kevin, how would you do the rest?
How would I do the rest, Professor Timmy? I'll show you how to do the rest, Professor Timmy. So part 4, well, we should put the equations together so it set it up like some kind of mathematics. So right here, we line them up against each other. It's kind of like elimination, but instead we just add these. And here, since FB is positive and FB is negative here, we could cancel them out because FB positive plus FB negative is 0. But FA and FA, there's 2 FA, so it would equal 2 FA. And here we add the answers. It's 4 plus 3.2, which equals 7.2. But however, that's in terms of 2 FA. We need 1 FA, and here we could find that by dividing by 2, and we got 3.6 newtons. And once you have FA, you could just plug that back into the original equation of both of them or just one of them. And right here, we see that FA plus FB equals 4 newtons. We plug in 3.6 for FA, and we solve for FB, and we get 0.4 newtons. And we'll try the other equation. We're supposed to get the same answer. So FA minus FB equals 3.2. We do 3.6 minus FB equals 3.2, and FB will equal 0.4 newtons.
And that is how you solve the problem. This is my colleague, Professor Kevin, and...
Well, I don't want to pressure you guys or force you to understand this. If you don't understand this, it's completely normal.
It's for earlier, Kevin. Yeah. Stupid professor. Kamehameha!
Ah! Get out of my house, Timmy. I'm going to charge you with assault and battery.
I'm sorry, Kevin. Can we be friends again?
We're not friends. We're not pals. We're not anything anymore.
Why not?
Because, Professor Timmy, there's a lot of tension between us. Every time I look at you, it's revolting.
But Kevin, we've been through so much together. We were just measly scalars before we met each other, and now we're vectors. You gave me direction in life, and I gave you direction.
No. I'm out of here. Alright, let's be friends.
In every life we have some trouble, but when you worry you make it double. Don't